Hello. Let's continue with our discussion on the trigonometry. Right, I'm back with you. Right, so still more, let's get joined. We're here now in this video. We are there now to finalize. This is the first part of the trigonometry where we need to know on how to use the ratios as such to work out the problems. What is here, as you can see, it's not very much an issue about the solving, but now, more importantly, you are given a problem, decision of choosing a ratio. That's why it's a problem amongst you students mostly. How do I choose a ratio? Which ratio to use? Tan, cosine, and also talk of the sine. So we are going to now have the last two problems here where we need to work upon, and then we review as such. So please take note of what I'm going to say here. It's more like a repetition, but the problems here now are different. Right. I just have two more problems. There are a lot of problems, cannot manage to do everything, but the guides we are discussing here, take note and go by them every time you are working out problems about trigonometry. Right. So what I have the first one and the second one, where the first one is just a diagram by itself, and you should expect that. Some problems will just be given different shapes, and out of it, when you read it out, try also to consider if there are some kind of shapes within the diagram which are talking about the triangles. That should give you a sense that, say, somewhere maybe trig has to be used. So like here, for example, we're given the diagram where they say find the value of BD. This one, the BD here, right? And angle BDC, BDC. So we have got this angle here and this side here, which are not known. Right. So here we are. Get the target, right? Our aim is there to at least choose a ratio side. So let me split this board here now into two parts. Solution. Right. So it's like the teacher told us something in the previous video. Let's see if that one is maintained. And here in this case, what ratios are we going to choose in this case? So if I look at this one, that figure, we are talking of side DB. So usually when you're given complicated talk of the diagrams, meaning not difficult diagrams to understand, but rather talk of the diagrams which have got a composition of different shapes. At least you need just have to concentrate on part of the diagram. Depict that part which you feel can assist you to work out a particular problem, right, or a particular item. So like here, we may not even concentrate on the whole diagram as such. Why in actual sense, I'll need to find the value of BD. But what I'll do, I'll just depict part of that shape. So in this case, I'll focus on triangle ADB as such. Because to me, I've seen that what I have here is a triangle which is just right angled. It has got every story of what I've already learned above the what? Trigonometry. So I should not hesitate. In that case, I'll try that one first. So what do? I'll write here as this, and sometimes just given to draw it, the depicted part of the diagram. So that diagram has got a situation which looks like this. If I'm just focused on that triangle, I've depicted this triangle because part of it is the variable that is of my interest and need to work out upon. So the triangle carries the variable BD. So I'm picking this one with the BD attached. So here it'd be like this. I can draw it separately, and I have hopes that you should also be doing the same. So that the one who is marking your work should be able to see the logical presentation of your work, that what is it that you're trying to say. So I'll take ADB and present it as such. This angle is 20 degrees and this one is 10. So the question say BD. I have no need to use the whole of that at the same time. So my BD here is this. So I would like to work out on that one, like that. Right. So when I look at this, following what the teacher told me, the guides on how to find the side using the trigonometric ratios, he mentioned it. One, what I said was this. Yes, my decision is to use the trig. I want to choose one of the ratios, but how do I get the ratio? I'll first of all focus on the variable of the side C, in short, that they're asking me to find. What is the name of that side in relation to a particular given angle? So in this case, we are referring to this angle as the acute angle, either angle theta. So if you look at this angle here, in relation to the side that they're asking you to find, you'll be able to realize that this side is defined as the opposite side. This is the opposite side to angle 20 degrees. And now, what sides have I been given out of the remaining two? Oh, you'll be able to see that here we have remaining sides like AB and side AD. So here the side AD is given as 10. So I will capitalize on that to come up with the what? Name of the side, so that I should have a guide as to which ratio to take. So I have got DB is opposite side, and the side given here is 10. If I define that side, you find that side is the side that is opposite right angle. And definitely that side is defined as what? Hypotenuse side. Look at that. So now it means we are now talking about opposite and hypotenuse. So if you look at the weight itself, so ka, toa, three sets of letters. You'll be able to see that the S is sine, the C is cosine, T is tangent. So we talk of the sine has opposite to hypotenuse, cosine adjacent to hypotenuse, tangent opposite to hypotenuse. So look at the pairs of the word. Okay, look at the two letters that define up the ratio. AH, OA, then here OH. You find that OH about what you have it here is related to S. So it means the ratio that I need to use here in order to find the value of BD is what? Sine ratio. So I'll not even hesitate there. What I'll do, I'll just go straight into business and then have my choice. That is sine. So I write like this. Sine of 20 degrees is equal to opposite over hypotenuse. So my opposite side happens to be DB. As I've asked me, you can even call it as what? BD. To what? To 10. Like that. You see what I've done here? How I've chosen this one. Name of this side, they're asking me to find opposite side. This side I'm already given is hypotenuse. A ratio involving the hypotenuse and opposite. In this case, is the sine. So I light it. Everything was related to what? Angle 20 degrees. So I have to light it. Sine of 20 degrees is BD to 10. Then I have what? An equation. So what do? Let me just solve this equation and find the value of BD. So you'll be able to bear with me that what first we do here is first of all to get rid of the fraction. Multiply both sides by what? 10 as a denominator. So here times 10, you have got 10 sine of 20 degrees. Here times 10, you get what? 10 and 10 cancels. And the answer you have there is what? BD. So it's BD just equal to 10 product sine 20 degrees. So here you write and say, therefore, the moment like this one is as good as lighting, and the opposite way, BD is equal to 10 sine 20 degrees. Right. So what is it that now we are remaining? Nothing else difficult. Here you just multiply 10 by sine of 20. You go on the calculator and find the sine of 20, and what you have there, you find that sine of 20 is 0.34, 0.34. Then what? 20. Right. That's the sine of 20 degrees. Then finally, what do? Just take the product of the two values, and at the end you get 3.4. That's what? 3.42. You can correct that one maybe to one decimal place now this time around, then you'll be able to appreciate that BD is equal to 3.4 centimeters. That one is done. Right, so now we're using the sine. Lastly, on the same problem here, we are asking to find the value of angle what? That is the BDC. BDC. So this time around, we consider this side here as 3.4. That one. So we want to find the value of this one here. So which means now in my diagram here, now it means this is 3.4. We would like to work out on the value of that. Right. So by what we did earlier in the previous video, you'll be able to appreciate that the tactics of which remains as such, and we are there to use them now. How? We are also going to use the same procedures on to choose how to choose the particular ratio. I have this side, I have got that side. Angle is this one, just like the included angle between the side DB and the AB. So this side is the hypotenuse side, this one is adjacent side. So the angle we find is included in between DB, in between adjacent side and opposite side. So you go on, what is the name of this side? It's hypotenuse side, 10 I'm given, and this side I've already mentioned is the opposite side. So which relation defines opposite and the talk of the adjacent at the same, sorry, that's the talk of the adjacent and the opposite side at the same time. This is adjacent, I light here to this, and this is hypotenuse along his side. You'd find that the ratio there required, the ratio that is required there is the cosine ratio. Right. So I'll write it the same to say cos of angle that is what? BDC, angle BDC is equal to what? Adjacent to hypotenuse. So which means I'll divide 3.4 by a 10. That's what I'll do there. So when we do that, what do we have? No, let's not go that side. We are talking of this angle here. Like I was going towards this angle here. We are not supposed to find that one. But now differently, we are working out a different story here. Yes, this is adjacent. This is the talk of the hypotenuse side. If we are interested in this one, this is angle ADB. You can continue with this one, but here you'll be able to find angle what? Talk of the ADB. But our interest here is not this, but we are focusing on this angle in the other triangle, Look here. Look again, not this one. Right. So what we have here, let us first of all lab this one out. This what we wrote here, where they are varying the value of angle ADB. But we are not asked the value of angle ADB. If you want to find the value of ADB, yes, you can proceed forward what we already started. Or else you just get the angle sum of the triangle, add this and this one, you find this one out. But our interest is this. So which means in this case, our triangle has to be extended further if our sketch is to go. So which means this one will go toward this side and this one comes like this. Here we are given 7. So this one remains as such 3.0, that talk of the 4. Right. So sometimes what we would do here is just a matter of redrawing that triangle as I previously indicated when I'm working out the value of BD. You can just draw a little sketch here to say, since now I would like to find the value of this angle here by that. So it means I'll just concentrate on this triangle DBC. Right, so we have to redraw this one by just only depicting DBC aside. Right, sorry, that time we are focusing on this one, but the question demands of this. So let's concentrate on what is required at the moment. Right, so which means in this case, the moment I've extended this one out, it means we are interested in triangle DBC. So here you come and just draw this one DBC and write here like this one in triangle DBC. It's the one that is going to help us to find this. So you take your that's a ruler and draw that part depicted like this one. Look at this, and then you have it like this. Right. So this is our D, this one, this is our B, this one, and this is our C, this one. This is right angled as it is here. So this side is 7. So I'll write here 7, but this is the 3.4. I'll write that one 3.4. So this one here is as good as having this one here. Our interest is this angle here, as it was here, and again the main diagram like that. Right, so allow me to lay this one out so that we could have a space and to avoid the loss of lighting on the board that can distract us. Right, so that's it about the second part of the question. Angle BDC. Right, so the same explanation follows. This side we are given and we have found it is adjacent to this angle, and this side here is a hypotenuse. So still more we maintain that we go for the cosine, adjacent over hypotenuse. So I'll still write like say cos of angle what? That's a BDC is equal adjacent side 3.4, hypotenuse side 7, like that. I can choose tan here. I can choose side. Unless if I want side, I have to work out the part of this one. You can do that one by Pythagoras theorem. It works. Right, so let's proceed with this. So as usual, we need to present the cosine of angle in the form of the distal fraction, not like that proper fraction. So I have to divide 3.4 by 7, and the result of that one, what we get from there is 0.4857. You have a calculator there, you can also go through that one. Try to divide 3.4 by 7. You get 0.4857 to 4 decimal places. Right. So as I earlier indicated that time to say like when we are finding the value of the angle, we could always talk of the inverse or part, which is just like an inverse of a particular ratio. So here it means this one is contained here, this one can give you this one. So if I would like to find the value of angle BDC, I have to take the inverse of this. So I'll write here cos inverse of 0.4857. I'll be able to appreciate that from the calculator, the value that we get from there is 60.9 degrees, which is just like 61 degrees. Right, so the angle here should be 60.1, but to the nearest, that one should be what? 61 degrees. So this is the way we do. Right, so I may not exhaust everything. The other part, it will be there for you to practice. What is more important? Get to know the ratios, I repeat, and also see how we choose a particular ratio when finding the side and also when finding the what? The angles as such. So the three problems that we have just done here are enough to give you the guide and the story attached. So this other problem here, the last one, I'll just have a discussion with you. It's a problem which can be used to work out the value of a particular variable, but with now several ways. So we just have to discuss here and there, and you have to try that one by any one of those ways that we're going to discuss here. Right. Let's look at it. We are given an equilateral triangle, right? So I'll draw a triangle, but first you have to understand that we have got different types of triangles. So the moment you are given, is this an adjective to the triangle? Ask yourself, what type of triangle is equilateral? So by JCE, you are there, I think, already. Known that say a equilateral triangle is a triangle which has got all sides equal. Right? And then it means all angles must also be what? Equal to each other. So when you're drawing a sketch, present it in such a way that your sketch should at least be close to those properties of the equilateral triangle. All sides must be equal and all angles equal. So this is my sketch. Right. So what do you do there? You can describe it by any letters of your choice in the vertices A, B, C, but there indicate that this triangle is equilateral by having those marks telling you that the angle sides are equal. And we are told that each side is 10 centimeters. Then this is 10, this is 10, this is also what? 10. You write down what is there in your question. So at the end, after you have indicated everything, you'll be able to be guided, sir. Now the direction I'll take is this one. Right. So now they're saying calculate the height of the triangle. what is the height of this triangle. Right. So when talking of the height, we're talking of the perpendicular line that touches the base and the vertex up there. Because the vertex is the topmost part of the triangle. Right, so we talk of the height. So in this case, I will connect a line from here, but that should be perpendicular to the base. So that line will be drawn like this. Light, like this one here. So this is the base and it's right angled. Let's take it as this one is right angled D. So that's what we'd like to find. So as a student, you are there to figure out, this is a triangle. Right, how do you find the variables in the triangle? The story comes in Pythagoras and trig. So you look at that one, which will be the appropriate way of doing it. How do I find AD as such? So if you can look at this one, you'll be able to figure out like first method as a student. If you can look at this one, very critical, by the what we are given here, you may be able to see that if you attach the properties of the equilateral triangle, you'll be there in the position to appreciate that if I've left to find the value of AD, you'll be able to realize that once you have got a perpendicular line from the vertex to the base of that one side of a triangle, which is the equilateral, you'll be in the position to consider that this side or that line, which is the height, bisects that side into two equal parts. Only in equilateral and isosceles what? Triangle. And you can prove that one by congruency in triangle ADB and triangle ABC. You find the two triangles are congruent to be able to appreciate that side DC is equal to side what? BD. And then what do? You just divide this side in two parts, equal parts. Then from here up to that is 5, and from here up to that is what? 5 centimeters. As such, if you pick any one of those two triangles, either this or that, you have a story that goes something like this. Look at this, and here is your D, this is your A, this is your C, this is 10, this is 5. So if you may ask you, how can we find the value of AD, which is the height in this case? You'll be able to see that the first method you learned about the triangles in Form 2 works. You can use the Pythagoras theorem. That's the first method. So I'll need you on your own, where you are, use Pythagoras theorem to find the value of what? AD, because that is one of the methods. Right. If you don't want to use the Pythagoras in this case, by what we have explained here on the board, you'll also be able to consider that if you attach more properties of the equilateral triangle, you tell me that this angle must be 60 degrees. This also be 60 degrees. All angles in the equilateral triangle are equal. And if this line is going there, definitely when you're going to prove that this triangle is congruent to that triangle, you appreciate that this angle must be equal to that one. So if the whole of this one is 60, then definitely this one must be what? 30 degrees, this one is also what? 30 degrees. Right, so 60, 60, 90 give you 180. So one asked me to find the value of AD. So as I said, take note of the sides you'd like to find. What are the names? AD in relation to this angle here, 30 degrees now. AD is adjacent to this angle. And the AB is what? Hypotenuse. So if you use opposite and if you use the adjacent side and the hypotenuse side in relation to this angle, you can use the cosine. So here you can use the first one, Pythagoras, secondary, from this, by realization of the factors of the equilateral triangle, you can use the cosine of what? 30 degrees. You'll be able to find the value of side what? 80. You may say, no, let me consider this side here and this side. Where you'll be talking of what? This side and this side adjacent to 60 degrees and hypotenuse. So it means you can also use the cosine of 60. This is adjacent, this is hypotenuse. So if you talk of the cos, this is the third one. You can use cosine of what? 60 degrees. Adjacent over hypotenuse. It will give you this one. Cosine of this, cosine of 60 degrees. Not cosine of 60, not cos, because the sides are already given. But now we talk of the opposite and hypotenuse. This side, if you consider the 60, this is opposite side. Look at this one. This is opposite to this one. Right? Cosine is already given for this side and that side, but now talk of the side you're given here. That one is what? This one is the opposite side to 60. This one is the hypotenuse. So opposite, hypotenuse, that is sine. So here it means you can use the sine of what? 60 degrees. You find the value of AD. Right, so this sum has got a lot of story within it. So it's just like your preference to choose which one to use. Pythagoras theorem can help you to find the value of AD, which is the height, by what we have explained here. Secondly, you can use cosine of what? 30 degrees. Lastly, you can use sine of what? 60 degrees. They are all going to help you to find the value of AD. And I expect the values should be the same. Right. So I want you to use the sine of 60 first of all. Secondly, Pythagoras, then lastly, cosine of 30. That is your assignment. As such, thank you very much. Let's end here right at the moment. We'll meet again in the other part of the trigonometry. Thank you very much for being together.